Welcome to your weekly introduction videos. This week we're going to be looking at finding volumes and surface areas of some more complex shapes, specifically spheres, cones and pyramids. But before we do that, just want to check that you are able to do volumes and surface areas of some more basic shapes. So here we have a triangular prism and a cylinder. Can you stop the video please and have a go at calculating the surface area and the volume of each shape? Okay, hopefully you've done that. So you should know that these are both prisms, okay? And you should also know that the volume of a prism follows the formula cross-sectional area times the length or height or depth of the shape, okay? So if I want to know the volume of the triangular prism, it's going to be the area of the triangle, which is 3 times 4 divided by 2, times the length of the shape. Okay, and that is 72 centimeters cubed. Okay, 3 times 4 is 12, divided by 2 is 6, 6 times 12 is 72. Okay, so the volume of the cylinder is the cross-sectional area, which in this case is circular, so that's pi r squared, times by the height or the length or whatever you're going to call it. Okay, so it's pi times 36, because 6 squared is 36, times 15. Just use a calculator now. 36 times 15 equals 540, so that's 540 pi centimeters cubed. Okay, now you can leave your answer in terms of pi here, depending on what the question actually asks you for, or you can use your calculator to do 540 times pi, and then write your answer to 3 significant figures, which will be 1,700 centimeters cubed to 3 significant figures. Okay, so that's volume. Hopefully it should be easy, just using that. They're both prisms, so it should be very straightforward. Okay, now surface area is a little bit more complex. Remember, with surface area, what you need to do is first look at how many faces there are on the shape and determine the shape of each face. So for the triangular prism, I've got 2 triangles. And my 2 triangles have an area of 3 times 4 divided by 2, which is 6. And the other triangle is also 3 times 4 divided by 2, which equals 6. Okay? Now I've also got a rectangle here. I'll call that shape 3. Okay, that rectangle is a 3 by 12 rectangle. Okay, hopefully that's obvious. And then I've also got one at the bottom here. I've got another rectangle. I'll call that shape 4. And that is a 4 by 12 rectangle, which is 48. Okay, now I've got another rectangle here on the top, sort of a sloping rectangle. So the area of that, base times height, well, I know the base is 12, but I don't know what the height is. But I can use Pythagoras' theorem to work it out, because this is a right angled triangle. So I know the height of it is going to be, let's call the height of it h. H squared equals 3 squared plus 4 squared. So h squared equals 25, h equals 5. Okay, so the height of this rectangle is 5, so it's a 12 by 5 rectangle, which is 60. Now I know the area of all 5 faces. I just simply add up. So 12 plus 36 plus 48 plus 60 equals surface area equals 156 centimeters squared, because it's an area. Okay. Now for the cylinder, surface area is going to follow this formula here. Okay. I've got 2 circles. So that's 2 pi r squared. What I've also got is a rectangle that wraps around the circle. So that means it's going to have a base that is exactly the same length as the circumference of the circle, because it's got to wrap exactly around the circle. So circumference of a circle is equal to 2 pi r. So that's going to be 2 pi r times the height of the rectangle, which is 15 in this case, okay? So it's going to follow that formula there. So we're going to do 2 times pi times 36 plus 2 times pi times 6 times 15, okay? So that's going to be 72 pi plus, 30 times 6, 180 pi. Add them all together is 252 pi centimetres squared. So if you want to leave your answer in terms of pi, that is your answer. If you need to do it to 3 significant figures, do 252 times pi button in your calculator, which is equal to 792 centimetres squared to 3 significant figures. So make sure you read the question. Does it want the answer in terms of pi, or does it want the answer accurate to, say, 3 significant figures? Okay. Now, the good news for you is a lot of the formulas, you know, for example, the formula for surface area and volume of a cylinder is given to you, as well as some of the new ones we're going to learn, such as spheres, cones, and pyramids. All right. This information here is exactly what you will receive on the front. On the front of your exam paper. Okay. So you get volumes of pyramid, cylinder, cone, and sphere. And you're also given the curved surface areas of a cylinder, cone, and a sphere. Okay? But what I expect you to be able to do is to adapt these formulas depending on what information the question is given you. Okay? Now, for example, there are 3 types of cylinders that you could be asked about. You could be asked about a hollow cylinder. Okay? A hollow cylinder is one where you could put your hand right through it because there's no top and bottom. You could also have an open can, which is a cylinder that has a bottom but not a top. So you could put your hand in, but you get stuck at the bottom. Or it could be a solid cylinder where you cannot put your hand through it at all. It has a top and a bottom. So let's say you're being asked to work out the surface area of each of those shapes. Well, it changes depending on whether it's hollow, open can, or solid cylinder. Obviously, if it's a hollow cylinder, it's only the area of that rectangle that you wrap around. So it's just 2 pi r. If it's an open can, it's the area of the rectangle that you wrap around plus 1 circle. If it's a solid cylinder, it's the area of the wraparound rectangle plus 2 circles. Okay, so you need to be able to adapt the formulas according to the information that you've got. Another example, let's say you've got volume of maybe you've got a shape like this. Okay, it's a semi-cylinder. And you're asked to find the volume. Well, obviously the adaptation would be that the volume of a cylinder is pi r squared h, when a semi-cylinder is just half a cylinder, so you divide it by 2. So expect you to be able to adapt things in that way as well. Okay, so I'm going to stop the video there, and in the next video we're going to look at how we find volumes and surface areas of a sphere, a cone, and a square-based pyramid.